Hello, this is a video presentation for the General Motors cost-effective vision pick point system.
So last semester we focused on understanding how we're going to make the robot play operation. Now we are optimizing algorithms in each step to have the robot arm play the game operation, and it simulates the robotic arm movements for the smaller electronic parts in close confined spaces that we now see in manufacturing and automotive industries.
So this semester on the end effector team, we've expanded upon the vacuum suction design to be more precise, and we've also expanded for a linear actuator to be more precise when picking up the rubber band because we were running into issues for that.
So last semester, I was on the machine learning team, but we decided to make another division, make an electronics team, and we successfully programmed a vacuum circuit to turn the vacuum on and off, as well as the laser. And we're implementing a tilt sensor for the laser safety to turn it off when it exceeds a certain angle. And we're also implementing some buzzing circuitry. When the robot touches the side of the board, it will buzz, indicating an error.
Other things we implemented on the electronics team is a dynamic laser to have a laser aiming where the arm is always pointing. Cleaned up the Arduino circuit by adding 4 relay shields.
Moving towards our machine learning slide, we have a block diagram here of what we will be going over. And to start off with board calibrations, we have the robot take a picture, and with that picture, we run it through some code and take the corners out from the board, and with those corners, we can get the pieces.
So another big aspect of this project is creating a control panel for testing, where we can select a button from this little graphic user interface right here, and then be able to test pretty much any stage of the block diagram shown below.
Piece identification. You apply a filter to an image around a specific point, and then we find white concentration around that point. From there, we can identify pieces there.
Once we've calculated the center of the piece, we can apply a translation in order to center the robot above the calculated center of the piece. After that, we calculate an extraction path for the piece, execute that path, and then drop the piece in a predefined collection box.
Hello. In this video, I will be giving a brief overview of GM Digital Twin. Our members include myself, Simon Cawley, as project manager, Nate Remillard as our document chief, Jonathan Gratinger as our financial manager, Hunter Tripp and Harrison Thompson as our project engineers, and Adam Gardner as our project shadow. Our project is to create a digital twin of a GM cell and to display its functionalities to GM. Previous semesters have guided us to using Emulate 3D. This software allows us to create a digital twin that can either be simulated or emulated. Emulation can be achieved by connecting to the PLCs with software such as Fanuc RoboGuide and Studio 5000. They would then report back to Emulate 3D the values they receive, and Emulate 3D will apply them accordingly. Emulate 3D also allows for VR to be used in the software. This allows for real-world views without being in person. While using VR, you can interact with the cell, doing things like activating buttons, moving trays, picking up parts, and so on. Our goal is to define to GM what might be useful to them. Certain factors like the benefits of a function and the time consumed to do it must be considered. GM gives us opportunities to visit the cell we are working on. This allows us to get a full view of the cell and to see what happens inside a GM facility. Overall, we are grateful for the meaningful project with many options to explore and are motivated to work on them. Thank you.
We are the Blue Marble Security Power Pack team. So in background, a previous Blue Marble Security team worked on a similar project funded by CERC to improve the power storage capabilities of soldiers via the improvement of a battery rucksack frame and the capability to keep that battery pack in position. Another team worked on creating a CAD model and created a prototype as well. That project was completed successfully, but there was opportunity to improve.
So our project was redesigning a Molly 2 rucksack frame to integrate a battery system, which will be rechargeable and will also help reduce with weight.
In summary, our project's target customer is military personnel. We're building upon previous semesters' work to enhance system integration. We currently have a full-size prototype for the frame as well as a prototype electrical system.
For the current CAD work, we are currently working on updating the CAD model of the drawers. The updated CAD model will have 4 compartments. Each of the compartments will have a battery cell pack within it. The top of the drawer will be decreased by about 0.02 millimeters to allow a larger clearance. The larger clearance will allow the drawers to open and close effortlessly.
Due to the reconfigured drawers, we have conducted an exploration into thermal simulations in order to discover if additional cooling is required for the project. The drawer redesign requires new battery configurations that require load and longevity testing. The new batteries will also be spot welded together to increase robustness and sleekness for the integrated prototype. The updated battery configurations require new wire gauges, management systems, and output boards.
So kind of to summarize on all the work that we're doing, we have a semester end goal, and that's we'd like to complete an integrated prototype, and we plan on doing this through improving the previous drawer design and increasing the electrical functionality. This will be accomplished by continuing with all of our current work, and if time permits, we'd also like to do a business analysis.
This is the project Friendly Forces ID within Blue Marble Security Enterprise. This project has the scope of creating a project with a secure communication between groups, which will allow for them to recognize those that are around them. Using this system will be safer than others while interacting with nearby groups, and the device will be built using commercial off-the-shelf parts. The specifications for this device is for it to be handheld, wireless, powered by a battery, as well as, again, using off-the-shelf parts or commercial parts. Here is a signal send demonstration. You can see as I press the first button, it sends a signal and the other one recognizes it. And again, from the other side, I press this button, the other device recognizes it. Moving on. Future add-ons to this project could be upgrades to enhance the capabilities of the device, including technology upgrades such as increasing the signal strength, reducing power consumption, and more. Thank you. This is the CERC Power Simulator project, which is also part of Blue Marble Security Enterprise. For our team, we have myself, Joel, Jacob, Kyle, Andrew, Gavin, Caden, and Amanda. With this project, we are to create an electrical power simulator for a small submersible. This submersible has many important systems that are operated by electrical controls. Using this submersible requires a significant amount of training, and as such, a key point is to being able to understand all aspects of the electrical controls, and this simulator aims to make that learning process easier. The project objective and deliverables has the creation of a realistic simulation using Unity, a simulation-based software that is capable of implementing realistic controls and responses to physical and subsequent changes. This simulation will be able to simulate the varying electrical switches and their effects on the submersible. We need to ensure that the simulation could be added upon in the future for things like the ballast system or trim and steering. In the simulation, it is required to have the submersible pre-programmed with failures, and these failures will help the operators learn by requiring them to fix the problem within the submersible. The simulation then needs to be installed on a secure PC and delivered to the customer. Here's a little bit of the switch implementation with the project. Use of Unity for simulation allows for the importation of objects like CAD models. It allows for a change in characteristics to be made, such as the switching the light value or the switch value. Other objects are able to be imported. A large variety of objects are suitable for use in Unity, as shown here. These materials allow for an immersive simulation to be created. Here's a little bit of a demo of the use of these aspects. Here we can change the view, flick the switch on, which changes the physical look of it and changes the color of the light. Thank you.
Hello, this is the CERC Everything tablet, and I'm the PM, Alex Gilliland. Here are our team members, and our project purpose is to develop an easily expandable electronic manual that will guide Navy personnel through training, routine procedures, basic maintenance, and through emergency events within a submersible. Here's our home state of the GUI. As you see, we have all the engineering buttons linked, and especially that emergency button, which is clearly defined. And on this emergency page, it makes it easy to attend to casualty procedures and gives extreme accessibility in case of emergency. It is also an easy to navigate layout with images and clear visual cues. And in order to extract the files from PDFs into HTMLs, the reason we're doing that is to preserve the formatting as well as make some of these tables that we were provided editable. Thanks so much.
Blue Marble Security is working with Oshkosh Corporation to research, conceptualize, design, simulate, build, evaluate, and integrate a complete suspension system for a 50 to 70 ton tracked vehicle. The tracked vehicle in question is based on publicly released information on the M1A2 Abrams tank that currently uses torsion bars as its suspension system. The goal of the project is to design a system that removes the poor survivability of the widely used torsion bars and minimize weight and cost. The project requires multiple designs to accommodate both 50 and 70 ton vehicles. Oshkosh provides system requirements to follow for the design outside of removing torsion bars from the system. The design has to allow for various motions of the vehicle, both typical and atypical. The vehicle also has to be able to traverse a multitude of obstacles of different sizes at certain speeds, maintaining safety and comfort for the passengers. It also requires the ability to function under certain damage conditions. These requirements come from several mil-spec standards that address testing procedures, durability requirements, and experimentation data analysis.